Hello students, in this video we are solving JEE Mains 2026 second April shift 1 maths questions from 16 to 20. Now look at this first question. If limit extends to 2, some expression equal to m. Now if the denominator is 0 in this limit, the numerator should be 0 because we are getting a finite value for this limit. Okay. Now if we substitute this 2 in the denominator, what will happen? You will get 1 here, 1 minus 1 is 0. That means the denominator is 0 if you directly substitute it. That means numerator should also be equal to 0. That is possible when this function is equal to 0. So 8 minus 5 fourths 20 plus 2a plus b equal to 0. That means 2a plus b equal to, this is minus 12. So we'll get okay. Since both numerator and denominator are 0, what we'll do is we'll use El Hospital rule. So by using El Hospital rule, we'll differentiate numerator and denominator. If we assume this as g, then the numerator changes to cos g into g dash. Since g is equal to 0, cos g becomes 1. And let us find g dash. What is g dash? G dash equal to 3x square minus 10x plus 8. If we substitute 2 here, we'll get 12 minus 20 plus 8. So a minus 8. So we are getting a minus 8 in numerator. And in denominator, what we'll do is we'll use UV method. So first 1 by 2 root x minus 1 for first term into ln x minus 1 plus, we'll write the same thing here, root x minus 1 minus 1 into ln x minus 1 becomes 1 by x minus 1. Now if we substitute 2 here, we'll get 0 here. Then here we'll get 0 once again. So the whole value becomes 0. Since the denominator is 0, that means the numerator is also equal to 0, from which we can conclude a is equals to 8. Now since the both numerator and denominator are 0, once again we'll differentiate numerator and denominator. So no numerator becomes, here we are differentiating dy dx of cos g into g dash. So we'll get minus sine g into g dash plus cos g into g double dash. We know that the value of sine g is 0, so whole term becomes 0, and cos g is 1. So we just have to find g double dash. Let us find g double dash here. So g double dash equal to 6x minus 10. If we substitute 2 here, we'll get minus 12 minus, which is equal to 2. So the numerator is 2. And coming to denominator, let us solve this denominator properly. So first, we'll treat this first term as uv. So 1 by 2 u dash becomes minus 1 by root x minus 1 into v dash. This becomes 1 by x minus 1. So u v dash minus v u dash. No, v u dash minus u v dash. So ln x minus 1 into 1 by 2 root x minus 1 by denominator square, which becomes x minus 1. So this is the first part. Then the second part, once again we'll use uv. So 1 by x minus 1 differentiation is minus 1 by x minus 1 whole square into, simply we'll write the other term, x minus 1 minus 1 plus 1 by x minus 1 into, if we differentiate this, we'll get 1 by 2 root x minus 1. That's it. So now let us substitute the value here. Since x is equals to 2, here it becomes 1. This is also equal to 1. And this is also equal to 1. What about here? This becomes 0. So in the first term, you are left with 1 by 2 plus. Now this is 0. And here this is 1. This is 1. This is 1. This is 1 by 2. So you are left with 1 by 2. So denominator is 1. So now the numerator is 2, denominator is 1. So the value of m is equals to m equals to 2. We know that a is equals to 8, m is equals to 2. If we substitute this a in the first equation, we'll get b. So let us find that. So b is equals to 12 minus 2a, that is equal to 12 minus 16, which is minus 4. So b is equals to minus 4. A plus b plus m is equals to 8 minus 4. 4 plus 2, 6. So the answer is option B, 6. Okay. Now let us look at question number 17. So if the curve y is equals to f of x passes through 1 comma e, satisfies the given differential equation, then f of e is equals to. Now let us solve the differential equation. The given equation is dy is equals to y of 2 plus ln x dx. So by variable inseparable, dy by y is equals to 2 dx plus ln x dx. If we integrate on both sides, we'll get ln y is equals to 2x plus x ln x minus x plus c. Since this equation is passing through 1 comma e, if we substitute e here, ln e is equals to 2 plus, this becomes 0, so minus 1 plus ln e is 1, so 1 is equals to 1 plus c, that means c is equals to 0. So our equation is ln y is equals to, if you take x common, x of 2 plus, not 2 actually, because 2x minus x becomes x, so x of 1 plus ln x. So let us find f of e. That means let us find the value of y if x is equals to e. So ln y is equals to e of 1 plus ln e is 1. So we'll get 2e here, ln y here. So y is equals to e power 2. That is option C. Now let us look at reading the question. The number of critical points of the function this in the interval minus 2 pi to 2 pi is equal to. Okay, now let us look check whether this function is continuous or not. So at limit x tends to 0, sin x by x will be equal to 1. So it is a continuous function. So to get critical points, what we'll do is we'll differentiate the function. So we will get weight. So there is a condition here, which is we will divide this interval minus 2 pi to 2 pi into 4 different intervals. First minus 2 pi to minus pi, then pi to 0, then 0 to pi, and pi to 2 pi. So at minus 2 pi to first 0 to pi, we know that sign is positive and s is also positive. So f of x is sin x by x. At pi to 2 pi, sin is negative and x is positive, so f of x will become minus sin x by x. At pi to 0, both the functions are negative, so it becomes positive. F of x is equals to sin x by x. At minus 2 pi to minus pi, sin x is positive and x is negative, so the function is minus sin x by x. From this, we can conclude that in the interval minus pi to pi, the function f of x is equals to sin x by x. And in the interval minus 2 pi to minus pi and pi to 2 pi, the function is minus sin x by x. So to get critical point, we'll differentiate it. First, let us differentiate this function f1 of x. So f1 of x differentiation is equals to vu dash x cos x minus sin x into x differentiation, which is 1 by x square, should be equal to 0 to get critical points. So from this, x cos x is equals to sin x and x is equals to tan x. So we will get different values for x here. One, we'll check it by graph later. Now let us look at the second function, which is f2x. F dash of 2x is equals to, we'll get minus x cos x, then minus sin x into x by x square equal to 0. From this, minus x is equals to tan x. So now let us draw the graph curve of tan x from minus 2 pi to 2 pi. Yes. So in the interval minus pi to pi, the y is equals to x axis is touching at three different points. And in the interval minus 2 pi to minus pi, y is equals to minus x line is touching at here one point. And on the right side, pi to 2 pi, it is touching at one more point. So in total, we are getting 5 solutions. We are getting 5 solutions, which is option C. Now, let us look at the question 19. So here the brackets represent greatest integer function and it is integral from 0 to 3. Here we are having x factorial. So what we'll do is we'll divide it into three different intervals, 0 to 1, 1 to 2, and then 2 to 3. If it is in 0 to 1, we'll get e power x plus e power minus x by 0 factorial. And here we'll get e power x plus e power minus x by 1 factorial. Here e power x plus e power minus x by 2 factorial. Since these two are same, we can combine them and write it as 0 to 2 e power x plus e power minus x dx plus this 2 to 3 e power x plus e power minus x. If you take 1 by 2 outside, then we can write this as e power x 0 to 2 minus e power minus x 0 to 2 plus half of e power x 2 to 3 minus e power minus x 2 to 3. This becomes e square minus 1 and this becomes minus 1 by e square and minus of minus plus 1 plus half of e power 3 minus e power 2 minus e power 1 by e power 3 minus 1 by e power 2. So if we solve this, we'll get minus 1 plus 1 gets cancelled. E square minus 1 by 2 e square is 1 by 2 e square and e cube plus half e cube. So that's it, plus half e cube and then minus 1 by 2 1 by e square plus this plus 1 by 2 e square is nothing but minus 1 by 2 e square, and finally minus 1 by 2 eq. If you take 1 by 2 common, then we'll left with e square plus eq minus 1 by e square minus 1 by eq. Let us check the options. It is option B, Bombay. Now, let us look at the last question. Here, y is equals to y of x be the solution of differential equation where y of 0 is equals to 0 and it also passes through alpha comma minus 1 by 2. Okay. So first let us solve this differential equation. So 1 plus sine x into dy by dx equal to minus of y plus 1 cos x. Let us use variable separable. So dy by y plus 1 is equals to minus cos x by 1 plus sin x. If we integrate both sides, we'll get y plus 1 here, ln y plus 1 here, and here we'll get minus ln 1 plus sin x plus because ln 1 plus sin x is differentiation of ln 1 plus sin x is 1 by 1 plus sin x into differentiation of sin x, which is equal to cos x. So, okay, that's it. That's fine. Now, this c can be written as ln c, and this becomes minus ln c of 1 plus sin x ln y plus 1. Minus goes to the power, so you'll get minus 1 there, and ln gets cancelled. Y plus 1 is equals to 1 by, you can write c by 1 plus sin x. Okay. Since c is constant, you can write it in the same way. Since this passes through 0, comma 0, substitute 0 here, you'll get 1 equal to c by 1. That means c is equals to 1. So your equation is y is equals to 1 by 1 plus sin x minus 1. He's asking us to find the value of alpha if it passes through alpha comma minus 1 by 2. Since it passes through alpha comma minus 1 by 2, minus 1 by 2 is equals to 1 by 1 plus sin alpha minus 1. So 1 by 1 plus sin alpha equals to 1 minus 1 by 2, that is 1 by 2. 1 plus sin alpha is 2. Sin alpha is equals to 1. Therefore, alpha is equals to 5 by 2. So the answer is option B. Okay, that's it for this video, and we'll discuss questions 21 to 25 in our next video. So subscribe and stay tuned.